Okay, question 4. First thing to notice, it's yet another algorithm, some pseudocode for you to understand. So you should be aware that these are very popular in exam boards exams. It says the algorithm in figure 4 is the binary search algorithm designed to search for a value within an array. So the binary search algorithm. Remember, binary search algorithm, what does it do? It searches through a list, trying to half the list as it goes and finding the value in there. So I'm just going to sort of remind you what it does with this list here. So if we've got a list, it's called an R for array, I suppose. 3, 5, 13, 43, 655, 872. Remember, let's say I'm searching for 655. Let's say I'm searching for that. What does it do? Well, it tries to find the middle value, first of all. So whatever the middle value means, well, you can see in the algorithm that what it does is the middle value is some left pointer. Okay, and in our array at the moment, we can see that it's a 1-based indexing method. So our indexes, remember in Python they would start 0, 1, 2, but they're saying no, we're going to start them off at 1, 2, 3, 4, 5, 6. So these are the indexes or indices. Okay, they're the indices 1, 2, 3, 4, 5, 6. And it starts off by making the left, I'll call that L in here. So L is left in this algorithm to be equal to 1. And right is the length of the array. Well, the length of the array is just 6 because there are 6 items in there. So that L is here and R is here. And what we're doing then is we're saying while left not equal right, well, in this case, the left is certainly 1 and the right is certainly 6. So they're certainly not equal. So this is true. This predicate here, this condition of the while loop is certainly true. And it calculates mid. So what is mid? Well, it's left plus right, which is 1 plus 6. 1 plus 6. So this is the calculation of mid. 1 plus 6, which is, of course, 7. And then it's doing a div, which is integer division of 2. So in other words, it's 7 div 2, because 1 plus 6 is 7. Remember, integer division does 7 divided by 2 and ignores the remainder. So 7 divided by 2 is 3 with some remainder. So therefore, this is 3. And it sets mid to be that value. So I'm going to call that M for mid, rather than having to keep writing M for mid. Okay, so that's what it's doing to start with. And then what it does, it says, right, okay, let's have a look at the value stored in the array at my mid point, which is 13. And it's making a decision now whether or not the thing that I'm looking for, which is 655, is bigger or less than that. Well, in this case, if we're searching for 655, it's bigger. So we know that it's thing that I'm searching for is not going to be in this half of the list because the list is sorted, remember. So it only works with sorted lists. So that's what we're doing here. So if the value that we're looking for, which is 655 in our little example here, is less than or equal to our value 13, it isn't, okay? It isn't. So we're going to go to this part of the code and we're going to shift the left up because we know that it's not in here. Instead of the left being there, the left's going to be here instead. Okay, we know that it's not equal to the midpoint because we've already decided that that it shouldn't be, but it's shifting the left to mid plus 1. You might be getting a bit of a hint straight away that actually should this be different between less than or equal to and equal to? Well, you'll see in the question that actually does make a difference later. So we're now shifted our left up to here, and now we're going to calculate the mid value. So that's going to be 4 plus 6, which is 10, then div 2, which is 5, so our mid value would come here. Okay, and then suddenly when we look at our mid our value in our mid position, we see that they're the same. We see that we've found it. So that's how binary search is basically working. Okay, now let's actually turn our attention back to the question now. That was just a sort of a quick recap on how binary search works. Okay, so we've got this algorithm. Complete the trace table for the algorithm in figure 4. The final value of left is already given. Okay, and here we go. So this line, we're going to go through the code line by line, and we're going to fill in the table as we go along. So we're looking at line 1. It assigns val to 43. So there we go, 43. The value of val is 43. Then it goes to line 2. It sets this array to be this 3, 5, 13, 43, 6, 55, 8, 72. Notice it's sorted. Has to be sorted for binary search. Then it's specifying that left should be 1. Here we go. And then it says right is the length of the array. Well, the length of the array is 1, 2, 3, 4, 5, 6. So the length of the array is 6. So right is becoming 6. And by the way, it might be worth putting your indexes on here because we're going to need to refer to those later. And now what do? We're going to check this while loop, the condition on this while loop. While left is not equal to right. Well, clearly these are different. So that's certainly true that they're not equal. So now we're going to execute line 6 now. Calculate mid, which is 1 plus 6 is 7. 7 div 2. Remember that's 7 divided by 2. Ignore the remainder. So it's 3 with some remainder. So mid is 3. Now what's array mid? That's array 3, which is the element with index 3 in the array, which is this value here, 13. So there's our value going into that table. So that's calculated that now. Now we're going to need to do this decision check here. If val, which is 43, is less than or equal to 13, is that true? Is 43 less than or equal to 13? No, it's bigger than. So this will not execute. Instead, this else statement will fire. So we're now setting the value of left to be mid plus 1. So the value of left, which is currently 1, is becoming mid, which is 3, add 1. 3 add 1 is 4. So this left is now becoming 4. Once we do that, we come to back here and then back up to where the while loop does, and we're going to test this condition again now. So is left not equal to right? Well, left is now 4, right is now 6. So are they not equal? Yes, they are not equal. Okay, 4 and 6 are definitely not the same. So we're going to execute this line again now. Recalculate mid, which is left 4 plus right 6. That's 10. 10 div 2 is 10 divided by 2, which is 5 with no remainder. We ignore the remainder anyway. So that's 5. So mid becomes 5. And then we're going to test this if statement again now. If val, which is 43, is less than or equal to array mid. We need to fill in array mid here. So that's the 5th index value of the array. So that's 655. So it says, if val 43 is less than or equal to 655. Yes, it certainly is. 43 is definitely less than or equal to 655. So we're going to do this line of code now. Right becomes mid. So our right is now 5. Okay, so once we've done that, we don't do the else statement because the if statement executed here. So we're back down to the end of the while loop and back up to the while loop again. So we're now back up to line 5, checking this condition on line 5 again. Is left not equal to right? Well, left is 4, right is 5. So that's true, they're not equal. So we calculate mid again at this line. Mid is left 4 plus right, which is 5, which is 9. 9 div 2, well, 9 divided by 2 is 4 with some remainder. So mid now becomes 4. And now we can fill in array mid. Well, array mid is array 4, which is 43. Okay, right, okay. So if val 43 is less than or equal to array mid, which is also 43, it is less than or equal to, they're equal to, which is less than or equal to. Okay, so they are equal to, so they're definitely less than or equal to. So we're setting now right to be mid. So right now, instead of being 5, will be the value of mid, which is 4. And then we're back up to the while loop again, and it says while left not equal to right. Well, left is 4, right is 4. So this are equal now. So this is now false. So this code will not execute. And then the code goes over to here, and there's nothing else left to come. So it finishes and it stops at that point. Okay. And you should have got a bit of a clue in the question, because notice that they fill in left for you here as 4. So if you haven't got a value of 4 in this column as your last value, you know you've gone wrong somewhere. Quite a lot of marks for that. Right, okay, let's have a look. Why would the binary search algorithm shown in figure 4 not work when the array ARR contains this? Okay, well, let's have a look. Well, let's try it out. So val is 43, and then array becomes this value. This, instead of that, we've got this 5, 3, 13, 872, 655, 43. Straight away you should know that this condition of having a sorted list for binary search is being broken. Okay, so we need to say binary search requires a sorted list. Okay, this list is not sorted. The list above is not. Okay, good. Final bit of the question. Now what I'm going to do again is I'm going to need this algorithm over there. So I'm going to make a quick screenshot of that, and I'm going to paste it onto the other page over here. Put this up there so I can refer to it as we're doing this. Now, there are alternative statements that could be used for on line 5. So here's our line 5 of the algorithm shown in figure 4 that would not change the functionality of the algorithm. Shade 1 lozenge to show which of the following lines could not replace line 5. In other words, there's something wrong with it. So let's have a look. Let's have a look at each one of these. Is it legitimate to say while left is less than right? Well, yes, it would, because it is a legitimate thing. You're starting to wonder whether would it change the algorithm or not, but it is at least syntactically correct. It's logically okay to say left is less than right. That's fine. And this not left equals right is just the same as not equal to, right? So not equal is the same as not equal. So this is okay. This is fine. This is fine. Let's have a look at this. While left is less than right and left is greater than right, hopefully you would see left is less than right and left is greater than right cannot be true at the same time. You can't have one number less than another number and the other way around. So for example, if you had 5 and 7, two numbers, this 5 is less than 7. So 7 can't be less than 5 at the same time. And that's what and means. It means both of them must be true. And that's clearly impossible. So therefore, this is the wrong answer. I don't really even need to check this one.